Ladies and gentlemen, welcome to this unusual conference, EMBC 2020. This is Yanru Chen, an undergraduate student from Jilin University, China, and I have been working on this research with Lawson Health Research Institute and Western University. It's a great pleasure for me to be able to attend this conference. Over the next 5 minutes, I'm going to be talking about quantifying microvascular alterations due to a pharmacological agent. My presentation will be divided into 4 parts. Let's start by looking at introduction. Diseases such as sepsis and diabetes affect the microvasculature throughout the body deleteriously. Novel pharmacological treatments are required to effectively treat the conditions. However, pharmacological agents themselves may present additional risks that must be assessed prior to drug development. A study of the effects of pharmacological agents such as carbon monoxide releasing molecules, CROM2, on skeletal muscle microvasculature may uncover novel treatments. This study processed microvasculature data emerging from an intravital microscopy imaging study. Now let's move on to methodology. In previous experiments, intravital microscopy generated 23 videos of rat muscle vasculature, spanning 1,000 times 1,000 microns over 30 minutes. CROM2 was administered to each animal approximately 10 minutes into the observation. We used intravital microscopy imaging data obtained from rat skeletal muscle, then processed them using Fiji image J semi-automatically, using a combination of multi-thresholding and available segmentation methods. Vessel networks were skeletonized. The skeletons were overlaid with the images to permit manual measurements of representative radii. The networks were refined to retain vessels that has red blood cells. Next, I'd like to take a look at results. As you can see from the figures, they showed representative network from the same animal before and after administration of CROM2 in a small region of interest. The black arrow in the left figure, it shows the direction of red blood cell movement. The effects of CROM2 were to dilate capillaries, recruit additional capillaries. The imaging data was processed to extract microvascular network before and after pharmacological treatment, carbon monoxide releasing molecules. It was found that CROM2 augments capillary radius as well as leads to capillary recruitment, factors that improve tissue oxygenation. The data indicates an increased capillary flow heterogeneity as some functional vessels didn't have flow in them post-CROM2 treatment. In conclusion, quantification of the network will review structural properties and permit assessment of tissue oxygenation. The purpose of this presentation is to show you a clear picture of the biophysical quantification of microvascular alterations due to biochemical stimulation, will permit development of novel pharmacological therapies and highlight associated risks. Thank you for your attention. And this is my presentation for you, and thanks to all the people in Lawson Health Research Institute and Western University. Thanks for listening.